So I'll be sharing my reaction and key insights about the system stability analysis, where we analyze poles, zeros, and system response using a MATLAB. So first, one of my biggest takeaways from this experiment is how the location of poles directly determines system behavior. So for both the manual computations and MATLAB results, I observed that when poles are located on the left half of the complex plane, the system becomes stable and its response eventually settles to zero. On the other hand, when poles move toward the right half, the system becomes unstable and the output grows uncontrollably. So I also learned that poles closer to the imaginary axis produce a slower responses, while poles farther from the left result in faster damping. So this really helped me connect the theory with an actual system behavior. So as for whether the video and the simulation were helpful, yes, definitely. So the MATLAB visualization made a huge difference because it instead of just solving equations, I could actually see the impulse response and the pole zero plots. So it made the concept of stability much clearer, especially when comparing different systems like G1, G2, G3, and G4. The differences in their responses help reinforce why pole placement is so important. So finally, as a future engineer, one insight I really found interesting is how stability is not just theoretical. It also directly affects the real world systems like control systems, control communication systems, and even robotics. Understanding how to predict and control system behavior using poles and zeros is essential for designing and designing reliable systems. So it also showed me how tools like MATLAB are powerful in validating designs before actual implementation. So overall, this experiment strengthened my understanding of system stability, and gave me a practical insight into how engineers analyze and design stable systems. And thank you.